So in this video, we'll basically cover the last lesson of the unit. So the first part of the unit, we really tackled the graph of rational functions. We talked about the properties of rational functions and some information you can extract from graphs of rational functions. For example, where it's increasing, where it's decreasing, where is it positive, where is it negative, so forth and so on. So hopefully you became a master with graphing rational functions. And then we move to the algebraic component of the unit, which is requiring you to solve rational equations and rational inequalities. So that's basically how we tackled most of our equations. We start you off with the graph, give you a picture, and then we give you the algebra, which is solving equations generally, and in addition, solving inequalities. Okay, so the last part, after you become really good at the algebraic component, you deal with the word problems. So this is what this lesson is on. So working with word problems with rational functions and rational equations. Okay, so the intensity of illumination is inversely proportional to the square of the distance of the light source. It is modeled by the formula I equals k over d squared, where I is intensity in lux and d is distance in meters. When the distance from a light source is 50 meters, intensity is 6 lux. I just want to add a very nice point. In grade 9, things that the relationship between the variables, they were not inversely proportional. This is a grade 12 thing. In grade 9, things were directly proportional. So what does directly proportional mean? When one variable goes up, the other variable goes up. One variable goes down, the other variable goes down. So, for example, hours worked and pay. If I work at a restaurant, the more hours I work, the more pay I get. And the less hours I work, the less pay I get. So those two variables are directly proportional. Inversely proportional means one goes up and the other goes down. So if I increase distance, the intensity of the illumination will decrease, and vice versa. Something else, if you took grade 11 chemistry, then you studied gases, and probably the last unit, you studied a lot of variables, and some of them were directly proportional, some of them would be inversely proportional. So pressure and volume, those would be inversely proportional, because if you decrease the pressure, the volume would increase, and vice versa. What else did you do? Temperature and pressure. So if you increase the temperature, you will increase the pressure. So those two variables will be directly proportional. Anyways, most of the things that you work in this unit, if you see a word problem, they would be inversely proportional because we want to work with a rational function. Okay, so you know what? Let's solve for the equation. I have to solve for k by subbing in the information here. 50 meters and 6 lux. So 6 and then 50. So k is, let's triple check, 15,000. So 15,000 over d squared. This is just your reciprocal of a quadratic, something that you're very good at. And I'm going to add a restriction that the distance, in fact the distance, is greater than 0. You know, we'll say greater than or equal to 0. It doesn't really matter, because at 0 is undefined anyways. So this one should look something this. Because if you're really, really close to that light source, and you're going to, the intensity will be really, really high. And as you walk away from the light source, and it's not very bright. Makes perfect sense to me. Okay, describe what happens to the light intensity as the distance becomes greater. So you can look at the graph. If you increase the distance, then the intensity diminishes greatly. Okay, so since as distance approaches infinity, I approaches 0 from above. Therefore, what can we say? The light intensity approaches 0 lux as distance becomes greater. Okay. In order to create a saline solution, salt water with a concentration of 40 grams per liter is added at a rate of 500 liters per minute to a tank of water that initially contained 8,000 liters of pure water. The resulting concentration of the solution in the tank can be modeled by the function C of t equals 40t over 160 plus t. C is the concentration in grams per liter, and t is time in minutes. And how many minutes will the saline concentration be 20 grams per liter? Okay, let's see. You know what? Let's C of t equal 20. Let's C of t equal 20, and what do we have here? We have a rational equation. How do you solve a rational equation? Multiply both sides by lowest common denominator and solve for t. But here, I just, 20 and 40, there's a common factor of 20. So I can make my life a little easier by doing 2 steps in one, like that. And then solve for t equals 160. You can easily take this and sub it, find c of 160, and then make sure it's equal to 20. So you know what? Let's check that out. 40 times 160 divided by 160 plus 160. Hey, what do you know? 20. Good stuff. So, therefore, in 160 minutes, the concentration will be 20 grams per liter. Awesome. Okay, is there an upper limit to the concentration in the tank? Explain. Well, there's lots of ways I can approach this question. I will just start off by giving you a graph. So this is linear over linear, so something you're very good at. So this is 40 over here. C equals 40. What's the initial concentration? The initial concentration is 0. Why is it 0 grams per liter? Because in the very beginning, it's actually pure water. And then you start infusing it with this 500 liter per minute, with this 40 gram per liter salt water at a rate of 500 liters per minute. That's why it gets more and more and more and more concentrated. And in fact, there's an upper limit. Because you're infusing it with a solution of 40 grams per liter, with a solution which is 40 grams per liter, there's no way that the concentration of the solution exceeds 40 grams per liter. You're using a 40 gram per liter solution. How is it possible that the concentration will exceed that concentration? In fact, you can make the argument that the concentration of the solution in the tank will always be less than 40 grams per liter. Why is it always going to be less than 40 grams per liter? Because there's an initial dilution of 8,000 liters. Okay, that means that no matter how much of this saline solution you infuse into the tank, you're always going to have 8,000 liters diluting that solution. But saying that, you will get over time, imagine this tank has unlimited capacity. If it has unlimited capacity, the concentration will get closer and closer and closer to 40 grams per liter, but unfortunately I'll never reach it. Okay, so is there an upper limit to the concentration in the tank? Yes. So you could just answer the question without this graph of C of t, but just using logic, it makes sense that there's most definitely an upper limit to the concentration in the tank, because it can't possibly be more than 40 grams per liter. You can say based on the graph of C of t, or you can say yes, because we are using a saline solution with a concentration of 40 grams per liter. Thus, the upper limit is 40 grams per liter. Okay, so let's see, for part C, what restrictions must be placed on the domain of C if the tank has a maximum capacity of 120,000 liters? So that means you must stop filling the tank at some point in time because it only holds a maximum of 120,000 liters. So we're going to solve for the time it takes to fill this entire tank if the capacity is 120,000 liters. So you have 8,000 to begin with, 8,000 liters to begin with of pure water, and you're filling it at a rate of 500 liters per minute. So you're going to ask, when is this equal to 120,000? Because that's going to be the upper limit on the domain of this function. Because we don't want to waste any water or solution. If you keep filling it, it'll just spill over. So that's 224. Perfect. So that means in 224 minutes, the tank will reach its maximum capacity. So therefore, the domain of C of t is equal to you can obviously not fill the tank at all, but if you do decide to fill the tank with the saline solution, you can only fill up to 224 minutes, and that's when it's at maximum capacity. Okay. Okay. We have a group of students who bought a couch for their dorm that cost $96. Unfortunately, 2 students failed to pay their share. So that means each student has to pay $4 extra. How many students were in the original group? Okay. So, to be honest with you, this question, similar to other rational equation word problems, the very beginning is the hardest part. You have to interpret the problem and generate the equation that models the situation. Okay, so when you do the homework questions, you're going to get different kinds of rational equations word problems, but really the hardest part is always the beginning, which is building the equation. Okay, so it costs $96, okay, and you share it between X number of students. That was your intention at least. But unfortunately, 2 people backed out. Okay, so that means you're not going to share it between X number of students. You're actually going to share this cost of $96 with X minus 2 number of people. Okay, so this is the pay per person after 2 people back out. And this is the pay per person originally. So obviously, because 2 people back out, it actually doesn't work out for the rest of the students because the 2 students back out, these people left over have to pay a bit more, okay? In fact, they tell us exactly how much to pay more. So because these 2 people backed out, this value here, the pay per person, is $4 more. Okay, each student has to pay an extra $4 because of the 2 people backing out. And that was the hardest part to this whole question. This is the equation that models this situation. When you buy a couch for $96 and when 2 people back out, each student has to pay an extra $4. That's what this equation is saying. And the solving part, that's pretty straightforward. Okay, so I'm going to just write it over here. So multiply both sides by the lowest common denominator, then you'll simplify to 96 x minus 96 times x minus 2 equals 4x, x minus 2. You can actually divide everything by 4 here because 4 is a common factor. Or you can just expand it out. I'm going to just divide everything by 4. So you'll get 24x minus 24x, and then that's going to 24 times negative 2, which is negative 48, and that would be x squared minus 2x. Okay, and then that would be x, whoops, that's a plus, x squared minus 2x minus 48. Simple trinomial, what multiplies a negative 48 and adds the negative 2, 8 and 6. So x equals 8 or x equals negative 6. That's based on our zero product property. So, one of them does not make sense. We have to reject negative 6. Clearly, I can't have negative 6 people in my group originally. Because x has to be greater than 2. X has to be a whole number greater than 2. Because I can't have half a person. And I can't have 2 people because I know 2 people backed out. So I had to have had more than 2 people to begin with. Otherwise, it makes no sense whatsoever. So negative 6 is not greater than 2. So I'm going to reject it. Okay, so therefore, there were 8 people in the group, in the original group. In the original group. You know what? Let's check. Let's check. So it's 96 divided by 8. And with each person, to begin with, their plan was, let's share it, and everyone pays 12 bucks. Because 2 people backed out, I'm going to take that 96 and divide by 6 instead. And then each person has to pay $16 instead of the $12 per person. And that makes sense. 16 and 12, there's a difference of $4. So because the 4 people backed out, each kid had to pay an extra $4. So it works out beautifully. All right. So the population of a town can be modeled by the function p of t, blah, blah, blah. P is the population in thousands, t is time in years, and after the year 2000. Okay, and what year will the population be 45,000? So we're gonna let p of t equals 45. Don't let p of t go 45,000, 45. Because p of t is measured in thousands. Super common mistake. 150t plus 30, 2t plus 9. This is simply a rational equation. You can divide both sides by 5 just to make these numbers a little smaller. But you know what? Let's just go for it. Let's just multiply both sides by the lowest common denominator. And just triple check. I've been making a lot of careless mistakes today, so let's just double check with our calculator. All right, 115t, 60t, and then 375. So t is equal to 6.25. Okay, therefore all right, what year is it? If t was 1, you'd be 2001. If t was 2, you'd be 2002. So 6.25, that's 2006 and a bit into 2006. But a quarter of a year into 2006 is still 2006. So in 2006, the population reaches 45,000. Will be 45,000. Will be 45,000. Okay. Sketch a graph of this function. No problem. Linear over linear. This is our friend. Doesn't cross a horizontal asymptote. Once again, linear over linear. 30 over 9. And the population, you get closer and closer and closer. Because the vertical asymptote is -9/2, somewhere here. So this is the branch you see. But since the restriction is t is greater than or equal to 0, that's why you only see a bit of this branch. But that's the graph. Okay. Town planners claim that they need not plan for a population above 75,000. Does the model support this conclusion? And the answer is yes, because you can say refer to the graph of P of t, but what you can say is, I'll just refer to graph, because I was going to say as P of t approaches infinity, as t approaches infinity, P of t approaches 75 from below, but you know what, the graph really says it's always less. When t is greater than or equal to 0, P of t is always less than 75. When 0, P of t less than 75, based on graph of P of t. And many of these word problems, when they give you the rational function, I would highly recommend you to give yourself the graph. That's the benefit of being able to sketch rational functions really quickly. If you have that in your back pocket, it really helps you when it comes to answering word problems involving rational functions. So I highly recommend you to sketch the graph quickly, even if they don't ask you for it, because a lot of the answers to these word problems can be answered with the graph. So say refer to graph, bam, full marks. Okay, so this handout or this lesson tackles word problems involving rational functions and rational equations. In the next video, we'll take up the homework for this lesson.